Welcome students once again in the new session. In this session, we will discuss our study about matrices, the new concept which is very frequently used in the area of business and commerce also. So, the subject matrices had its own origin in various types of problems. Of course, the basic is what to find out the solution of the system of linear equations is of extremely interesting. So, one of the main application of the concept of matrices is what we can find out the solutions of the system of linear equations using the techniques of the matrices. In the beginning, matrices and determinants were related, but they are completely thought to be inseparable. And the concept of the matrices was first coined or introduced by the British mathematician Arthur Cayley. So, the subject matrices had found applications in many areas like geometry, economics, statistics, and other fields also. For example, sociologists use the matrices to study the dominance within a group, whereas the demographers use them in the study of birth and survival, marriage and descent, class structure, as well as mortality. Matrices are very well used in game theory and allocation of expenses, budgeting for the products as well as various commodities, etc. Economists use them in social accounting as well as input-output model and in the study of inter-industry economics. So, before going further, let me first try to define the term matrices. Let us take this one. Suppose we have what is the performance? The performance is described as follows. A secured 75 marks in accountancy, 65 marks in chemistry, and 80 marks in mathematics. B secured 50 marks in accountancy, 58 marks in chemistry, and 85 marks in mathematics. Suppose this is a data. Right? This is the data of two students A and B, and they are appearing in three different subjects, or they appeared in three different subjects like accountancy, chemistry, and mathematics, and their grade or the performance or the marks obtained in these three subjects are mentioned in this table. So, if you look at the first column of this table, it represents the students A and B, and then second column marks of the students A, B in accountancy, then chemistry, and then mathematics. The numbers represented in the above data are said to form a rectangular arrangement if they are expressed like this. What does it mean? It means if the data given in this table can be arranged in the form of a rectangle. Rectangle means rectangle is a figure which has few horizontal lines as well as few vertical lines. So look at this arrangement. This is also the form of a rectangle because it contains two horizontal lines. This is 1 and this is 2 and 3 vertical lines. Right? We can write this data written in this table in this form. So here in this representation, the horizontal lines are called rows and vertical lines are called columns. Now we are going to use the mathematical terminology before defining the term matrices or matrix. The horizontal lines, this is called the horizontal line, right? This is the horizontal lines and they are the vertical lines, right? Okay. So here in this data, The horizontal lines are called rows and vertical lines are called columns. What this data represents, the first and second row, this is row 1 and this is row 2. The first and second row gives the marks of the students A and B obtained in 3 different subjects, right? This is row 1 may be A, student A, row 2 may be represented as student B, but we don't mention it. So row 1 and row 2 represents the marks of the 2 students obtained in 3 different subjects: accountancy, chemistry and mathematics. Now what about the columns? Similarly, first, second and third columns, they are the columns. See, rows are represented here. They are known as columns, right? Column 1, column 2 and column 3, right? First, second and third columns, they represent marks obtained by each student in accountancy, chemistry and mathematics respectively, right? Are you getting what I want to say? Row has the information of what there are 2 students A and B, how much marks they secured in 3 different subjects, and these 3 columns represents marks obtained by each student A and B in 3 different subjects: accountancy, chemistry and mathematics respectively. Hence, we observe that this representation of data gives a clear view of the data, and such a rectangular arrangement of the data having some horizontal as well as vertical lines as represented here before you is called a matrix, right? Now, before define, let me define the term matrix. How we will define it? So, as far as the basic definition of the matrix is concerned, an ordered rectangular arrangement of mn numbers having m horizontal lines, which are known as rows, right? Horizontal lines, we will use the term rows for the horizontal lines. They are horizontal lines and they are vertical lines, right? And in vertical lines, they are known as columns. So they are known as the row, they are known as the columns. I will not use the word horizontal and vertical lines, rather I will use the term row and column. So an ordered rectangular arrangement of mn numbers having m horizontal rows or n vertical lines, columns, is called a matrix of order m by n. Such an arrangement is enclosed in a bracket like this, right? We should enclose that arrangement in this bracket. So throughout this session, I will use this bracket to represent a matrix. However, in some books, you can also enclose them within this bracket. So it's not the issue, but you are using this bracket or this bracket, use one bracket throughout. You cannot change the bracket in between, okay? You should keep in mind. So what is the definition? An ordered rectangular arrangement of mn numbers having m rows and n columns is called a matrix of order m by n, right? So what does it mean? It means m into n, this is a number in fact. If I ask you, if I have given you, for example, understand like this, if I have given you 6 numbers from 1 to 6, for example, 1, 2, 3, 4, 5, 6. You have given 6 numbers and you have been asked, arrange these 6 numbers in the form of some rows and columns. So it's up to you. You have a number of ways which you can arrange these 6 numbers. The one arrangement is you can make a row 1, 2, 3, 4, 5, 6, enclose them in a bracket. This is arrangement 1. This is what? So this arrangement will be known as a matrix because it contains how many rows? It contains only one row and 1, 2, 3, 4, 5, 6 columns. So this is an arrangement of 6 numbers in one row and 6 columns. Second case, you can also write them like this: 1, 2, 3, 4, 5 and 6. This is also a matrix. You have arranged these 6 numbers in the form of one column, but it contains now 6 rows. You have many other, say 1, 2, 3, 4, 5, 6. This is also an arrangement. So what I want to say, I think you can understand, if you have given 6 numbers and you have been asked to arrange them as per your convenience in certain number of rows and columns, so you have many options to arrange them. So each option, if it is enclosed in a bracket like this, such an arrangement is known as a matrix. Right? Mn is what? Here Mn is 6. Mn is equals to 6. You are arranging 6 numbers in many ways. If every arrangement is being enclosed in a bracket or parenthesis like this, then such an arrangement is known as a matrix. So matrix is simply the arrangement of few objects, few items. The objects may be anything else, it's your choice, in the form of certain rows and columns, and finally they are enclosed in a bracket like this. Then such an arrangement is known as a matrix mathematically, right? The numbers constituting a matrix are called, their elements are entries. So see, for example, this is a matrix. It contains one row and one column. This is also an arrangement. This is also an arrangement. This is also an arrangement. So this is an arrangement of one number. This is an arrangement of two numbers. This is an arrangement of 3 numbers, and this is an arrangement of 3 into 3, that is 9 numbers. This is how the 9 numbers can be arranged in the form of 3 rows and 3 columns. If such an arrangement is being enclosed in a bracket like this, then the arrangement is called as a matrix mathematically. Right? Hope you will understand the concept of matrix. So what is important here in this definition is that what is highlighted in red color, ordered word, is very important. So let us look at the remarks. Remark 1, the word ordered in the definition of the matrix is very important because you cannot change the order of any entry or any element. Here 0, 1 and 2, 2, 5, 1, 1, 2, 9, 4, 5, 3, 6, 8, 0, they all are known as elements. We are not using the word object. We will use the word element or entries. Mathematical term is elements or entries. So the elements which you have arranged, they are known as elements or entries. So the word ordered in this definition of the matrix is very important because the matrix 1, 2, 3 is different. Look at this. If you are writing 1, 2, 3 is different from 2, 3, 1 or 2, 1, 3 or 3, 1, 2. So what does it mean? It means if the position of the elements are changed, then the matrix also changed. This is the meaning of ordered. Actually, orderedness simply is a very important aspect. Otherwise, you all are well aware with the tables, which we generally construct in our day-to-day life. Tables are also the most natural example of matrices because each table contains certain number of rows and columns. The tables are the most natural example of matrices, but the tables are not ordered. So the meaning of ordered is what? You cannot change the position of any element in a matrix, if we will change the position of any element, you will get a new matrix, number one. Number two, each position should be filled. Whenever you are representing any data in the form of a matrix, each position should be filled, or no position should remain vacant. But this is not feasible for the table. This is the basic difference between table and matrix. If any cell, any position in a table remains vacant, it is still considered as a table. But if any position in a matrix remains vacant, it will not be considered as a matrix. This is the meaning of orderedness. For example, if I write a matrix like this, 3, 2, 5, and this position is vacant, then this will not represent any matrix. So ordered simply refers to points. One, you cannot change the position of any element in a given matrix. If you will change, you will get a new matrix. Means 1, 2, 3 and 2, 3, 1, they are two different matrices, as well as 2, 1, 3 and 3, 1, 2. So all these four matrices are different, although they are having same elements 1, 2 and 3. The position of the elements is changed, therefore we get a new matrix. And number two, each position should be filled. No position should remain vacant. This is the meaning of orderedness in a matrix. This is the key point in the definition of any matrix. Point number two, the matrix is not a number, but it's an ordered collection of numbers. Matrix has no value. That we will discuss later. Matrix is not a number, rather it's an arrangement of certain numbers in the form of certain number of rows and columns. So we cannot call a matrix as a number itself, right? For example, this 2 is a number. If we write this 2 and enclose in a bracket, then this 2 represents a matrix where 2 is an element of the matrix. Here 3, 2, 5, they are known as elements. So simple 2, this is a number, but if this 2 is enclosed in a bracket, then this 2 represents a matrix having one row and one column, and this 2 is an element or entry of the matrix. And number 3, as I mentioned you, tables are the most natural example of matrices, right? And hope you understand the concept of matrix. Simply, if whenever a data is given to you, what is your objective? Your objective is, if you are able to arrange any data in the form of certain rows and columns, providing the conditions are satisfied, the arrangement should be ordered, and enclose them in a bracket. Such an ordered arrangement of the data will represent a matrix, right? Hope you understand the concept of matrix. Let us have a look of a general form of a matrix. How actually a matrix look like? A matrix consisting of mn elements is usually written as like this. See, this A11, this 11 is called subscript, right? A11, A12, A13, A1n, A21, A22, A23, A2n, A31, A32, A33, A3n, and finally we will get AMN, M1, AM2, AM3 and AMn. This is a matrix having m rows and n columns. So using this format, you can write down the matrix of any order, right? Start from A11. So what does it mean? This 1, 1 is what? Subscript 1, A11, the first subscript represents the row and the second subscript represents the column, right? So A11 means what? A11 is an element of the matrix which lies in the first row and first column, right? For example, if I say A31, So A31 will specify its position itself in a matrix. So A31 is an element of a matrix which lies in the third row and first column, right? A32. A32 is an element of a matrix which lies in the third row and second column. So you should keep in mind whenever you are writing any matrix, start from A11, A11, A12, A13, then A21, A22, A23, then A31, A32, A33, and then so on, right? A11 means A11 is an element which lies in the first row and first column. So start from 1, 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, first row. Then come to second row. A21, 22, 23, 24, 25, and then so on. Come to third row, A31, 32, 33, and then so on. So like this, you can write down a matrix of any order. For example, this is a matrix of order 3 by 3 because it contains 3 rows and 3 columns, right? So the above rectangular arrangement contains m rows and n columns in the general form of a matrix. Matrices are generally represented by capital alphabets. Whenever you are representing any matrix, it should be represented by any capital alphabet of English literature. A, B, C, X, Y, Z, it's up to you. On the other hand, their elements, right? They are the elements A11, A12, A13, A33, A32. They are the elements. On the other hand, their elements are being represented by small alphabets or by the numbers or any other. You cannot represent any element of a matrix by any capital alphabet. Be careful, right? What is shown here, on the other hand, this is the general form of a matrix. This is also another way to represent any matrix. A matrix A can also be written as C. A is equals to C Aij m by n. M by n means it contains m rows and n columns. Aij is known as the general element of the given matrix. By changing the values of I and j, you can write down any matrix. If I is 1, j is 1, you will get A11. See from here. If I is 1, j is 2, you will get A12. If I is 1, j is 3, you will get A13. Likewise, come to second row. If I is 2, j is 1, you will get A21. If I is 2, j is 2, you will get A22. Come to third row. If I is 3, j is 1, you will get A31. So, by changing the values of I and j, we can write down any matrix of any order from this general element of a matrix. This is another representation of the matrix. Both are almost same. This is the shortest way or shortest form to write down the matrix. That is the only difference. Otherwise, there is no difference between these two. Right. The next term is what? Order. Once the term matrix has been defined, then the second most important thing is order. What is the order of a matrix? So as far as the definition of the order of a matrix is defined, the order of a matrix represents the number of rows and columns of a matrix. What does it mean? The order of a matrix is defined as how many rows and columns a matrix contains is called its order. For example, if a matrix contains 2 rows and 3 columns, so its order will be 2 by 3. If a matrix contains 3 rows and 4 columns, then its order will be 3 by 4. So the order of a matrix represents the number of rows and columns of a matrix. A matrix is an arrangement of elements arranged in the form of rows and columns, And the order of a matrix, in fact, helps us in getting a count of the rows and columns in a matrix. So order of the matrix is helpful in what? If a matrix is given, if you know its order, the order of a matrix is 3 by 4, then it directly shows that this matrix contains 3 rows and 4 columns. Not only rows and columns, even the order of a matrix also helps us to find out the total number of elements or entries of the given matrix, right? So you can understand the importance of the order. By knowing the order of the matrix, number one, we can determine how many rows and columns the matrix contains. And number two, we can also determine how many elements are being arranged in the form of rows and columns. So by knowing the order of a matrix, we can determine both of these two terms. For example, the matrix 2 by 3, this is a matrix, right? Two numbers are there. We have written these two numbers like this. So this is a matrix which contains how many rows? It contains 1 row and 2 columns. So its order is 1 by 2. 1 by 2 we don't write like this. 1 cross 2 we write like this and we read it 1 by 2. Be careful. We write it as 1 by 2. In general, m by n, say this. We read like this, but we write m cross n. Be careful, right? M cross n means m by n. Okay. So 2 and 3, this is a matrix containing 2 elements. It contains 1 row, only 1 row, and there are the 2 columns. So its order is 1 by 2 because it contains 1 row and 2 columns. Take this matrix. This is a matrix which constitutes 3 elements, 2, 3, 6. Its order is 3 by 1 because it contains, see, row 1, row 2, row 3 and only 1 column, right? Rows are like this and columns are like this. I am telling you again. So it contains 3 rows and 2 columns. So it's a matrix of order 3 by 1. See this. This is a matrix. A number 2 is enclosed in a bracket. It contains 1 row and 1 column. So it's a matrix of order 1 by 1. Likewise, this matrix contains 2 rows and 2 columns. So it's a matrix of order 2 by 2. Likewise, this matrix contains 3 rows and 3 columns. So it's a matrix of order 3 by 3. Right? Let us take an example. We have just discussed a matrix can also be written like this. A is equals to Aij, right? Aij denotes the general element of a matrix. By changing the values of I and j, we can construct any matrix of any order, right? So example 1 is in the same direction. Construct a matrix A is equals to Aij of order 3 by 4, okay? This is a matrix and its order is 3 by 4. Order is 3 by 4 means it must contain 3 rows and 4 columns, right? Rows, right? Whose elements are given by this. Aij is given in this form. Aij is equals to 1 plus 3i minus 2j. Right? So what we know from here, we know the order of a matrix. The matrix which we want to construct, its order is 3 by 4. So simply first write down a matrix which contains 3 rows and 4 columns. See, I have written a general matrix having 3 rows, row 1, row 2 and row. This is row 1, this is row 2, this is row 3, like this is column 1, this is column 2, this is column 3 and this is column 4, okay? So it contains 3 rows and 4 columns because its order is 3 by 4, right? Okay, let me remove it. So we have taken the matrix A11, A12, A13, A14. right? Row 1. Row 2 will start from 2, A21, A22, A23 and A24. Third, A31, A32, A33 and A34. This is a matrix. Let us consider a matrix of order 3 by 4, and this matrix can be written like this. So what is left here? Find the values of their elements or entries A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34. How we can determine these values? We can determine these values from the element given from this, right? See, what is the meaning of A11? I have just told you in the last slide, this subscript represents their position, where this element lies. A11, how you will get A11 from here? If I is 1 and j is 1, you will get here A11, right? Put here I1, J1 in this equation. So if I1, J1, you will get 1 plus 3 into 1, 3, minus 2 into 1, 2. So 3 plus 1 is 4, 4 minus 2, that is 2. See, this A11 is coming out to be 2. Hope you understand how we calculate it, right? You can calculate anything. Say you want to calculate A23. So A23 means what? I is equals to 2 and j is equals to 3. So put here A23 means what? I is 2 and j is 3 in our equation this, given like this. So if I is 2, what you will get? 1 plus I is 2 means 3 into 2, that is 6, minus j is 3 means 2 into 3, that is 6, 6 and 6 cancel, this is equals to 1. So see, A23 is coming out to be 1 like this. Clear? Now let us take one more, A34. A34 means I is 3 and j is 4. So put here I is 3, j is 4. So A34 means what? 1 plus I is 3. So 3 into 3, that is 9, minus j is 4. 2 into 4, that is 8. So what is left? A34 is what? 9 plus 1, 10, 10 minus 8, you will get here 2. So see here, A34 is coming out to be 2. Hope you understand how these calculations are being performed. So by using all these calculations, we can calculate all the entries, all the elements A11, A12, A13, A14, then A21, A22, A23, A24, then A31, A32, A33, A34, and then substitute them, you will get a matrix like this. So this is a matrix whose order is 3 by 4 and its element or the general element is written like this. This is how a matrix is being constructed. So by using this approach or this technique, you can construct any matrix of any order, right? Now after this, we will discuss types of matrices, means how the matrices are being defined, right? Matrices are classified as follows. Number 1, row and column matrices. So very simple, row and column matrices. Row matrix is that matrix which contains only one row. It may have any number of columns, right? Row matrix is a matrix which contains only one row, but it may have any number of columns. On the other hand, column matrix is that matrix which contains only one column, but it may have any number of rows, right? See, this is a matrix which contains one row. How many columns it contains, we have nothing to do, although it contains 3 columns. This is a matrix which contains only one row. How many columns it contains, we are not concerned. So these two matrices are known as row matrices. Likewise, a column matrix is a matrix which contains only one column. So look at this. This is a matrix which contains only one column. How many rows it contains, we have nothing to do. Likewise, this is a matrix which contains only one column. How many rows it may contain, we don't have nothing to do with this. Although matrix 1 contains 2 rows and matrix 2 contains 4 rows. We are not concerned about the rows if we are defining column matrix, and we are not concerned about the column when we are defining row matrix. Case 2 is the null matrix. Null matrix is a matrix whose all entries are all identically 0. A matrix of order m by n means a matrix containing m rows and n columns is called a null matrix, or sometimes it is also known as a zero matrix if all its entries or elements are 0, right? The best example, if this is a null matrix, this is also a null matrix, this is also a null matrix, order of this is 1 by 1, order of this is 1 by 3 because it contains, and order of this is 2 by 2 because it contains 2 rows and 1 column. Its order is what? It contains 3 rows and 1 column, so its order is 3 by 1, its order is 2 by 2, and its order is 1 by 1, right? Next, square matrix. Now, in the definition, an ordered, what we use? An ordered rectangular arrangement. Rectangular means any figure which contains, which looks like this, right? And you know, this rectangle becomes a square. What happens if all the sides are equal? Means if they are the horizontal lines and they are the vertical lines. If these horizontal lines are equals to these vertical lines, then this rectangle becomes a square, right? This is rectangle. So we will use the same concept in case of matrices. A square matrix means what? A rectangular matrix becomes a square matrix if the number of rows and columns both are equal. For example, this is a square matrix because it contains 1 row and 1 column. This is a square matrix because it contains 2 rows and 2 columns. Rows and columns must be same. This is also a square matrix because it contains 3 rows and 3 columns. Rows and columns are equal. Are square matrices of order 1 by 1, 2 by 2, and 3 by 3 respectively. We simply call a square matrix of order m by m because rows and columns are same. So we don't write it like m by m, rather we say that the order of the matrix is only m because rows and columns are same. So we can call this matrix of order 1, this matrix of order 2, not 2 by 2. Rows and columns are same, so in place of 2 by 2, we call it order 2. Here, this is a matrix of order 3, not 3 by 3, because rows and columns are same. So whenever we are having a square matrix, its order also its order is also defined in different way other than a rectangular matrix, right? We simply call a square matrix of order m by m or a square matrix of order m, right? In a square matrix Aij, see Aij. See what is Aij? If I and j both are equal, say I is 1 and j is 1, then you will get here A11. If I is 2 and j is 2, you will get here A22. If I is 3 and j is 3, you will get here A33. So A11, A22, A33, what they are? These are the elements Aij, they are denoted by Aij. So Aij are known as diagonal elements, and the line along which they lie is known as principal diagonal or main diagonal. You know the concept of diagonal in a square. This is a square, then this is called the diagonal. So if the elements of a square matrix lying on this line, they are known as the diagonal elements. For example, if you take this case, this 1 and 2, they are the diagonal element, right? Because they are lying on the diagonal. And here in this is the diagonal element. 1, 3, 7 are the diagonal elements, right? Elements which are lying along the diagonal, they are known as the diagonal matrix. The next is the unit matrix or identity matrix. So students, I think we should stop it here and we will continue in the next lecture.